All right, gentlemen, lesson number 4. Quiz went pretty decent, not gonna lie. Pretty excited about stuff, so let's go. And to celebrate our wonderful quiz scores, wearing my all the work shirt. Okay, so moving forward, lesson number 4, proportional and non-proportional relationships. So we're gonna start with this problem and then lead into our vocabulary words to see what those two things mean. So Mrs. Cochran's planning a pizza party for her students. Sorry guys, you're not getting a pizza party. I can't eat cheese. Ace Pizza offers free delivery and charges $8 per medium pizza. A, super cheap. B, how do they not charge delivery? That's crazy. Let's keep reading. Scroll down, thank you, computer. Complete the table to determine the cost for the different numbers of pizza ordered. So if I only order one pizza, it's going to cost me $8. Fair enough. Well, what's going to cost me for $2? Or 2 pizzas, excuse me. So 8 plus 8, which would be 16. And if I ordered 3 pizzas, it would be $24. 4 pizzas would give me $32. And 5 pizzas would give me $40. Again, simple continuous addition, or because we are working on our higher level math skills, just simply multiplying. Again, not something too complex there. We like those. Step 2, for each number of pizzas, fill in the box to write the relationship of the cost and the number of pizzas as a ratio in simplest form. So the first one they started for us, I scrolled down too far. The cost of the cost is $16 for 2 pizzas. So how could I simplify that? Well, I could divide both numbers by 2. Wow, this is not wanting to respond today. Let me try that again. I can divide both numbers. Oh, that's okay. Divide both by 2. 16 divided by 2 is 8. 2 divided by 2 is 1. So that will reduce down to 8 over 1, which is the same thing there. Okay, let's talk about the cost of 3 pizzas. Well, again, I could divide both of these by 3, which would reduce down to 8 over 1, which is okay. And then I have 32 for 4 pizzas, and 32 and 4 both divide by 4, which gives me, would you look at that? I think we might be coming up with a pattern here, gentlemen. And then I had 5 pizzas, which cost me $40, and that also divides by 5, which is also equal to $8 for 1 pizza. So what do we know about these simplified ratios? What kind of conclusions could we draw? Well, I could say that each ratio reduces down to the same value. Every time I increased the amount of pizzas that I purchased, my cost increased proportional to that amount, which leads us into definitions. So what does it mean to be proportional? I've used that word a couple times now, so let's look at that definition. Proportional is 2 quantities that have a constant ratio. Constant means the same, continuously increasing the same amount. Pizzas, every time I buy a new pizza, it's going to cost me $8 more. That continuous rate of 8 would be my constant ratio there. What happens when they're not the same? So then we'd have non-proportional, which are 2 quantities that are not a consistent ratio. And then, just because I want to make sure that we talk about all words, equivalent ratios are ratios that simplify to the same value. Number 1, Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So first, we're going to start by simplifying everything and seeing if I can reduce down to an equivalent ratio. If I get equivalent ratios, then it is proportional. If I don't get equivalent ratios, then it is not proportional. So again, 18 over 1, that can't really simplify anymore, so we're going to leave that one alone. So I can start by 36 over 2. Can I take 36 divided by 2? Yes, I can. 36 divided by 2 is 18. 2 divided by 2 is 1. So far, our first increase of time is consistent. But just because it's consistent for the first one does not mean it's going to be consistent the rest of the way. We have to continue checking the rest of the table. So what about $54 for 3 lawns, or 3 hours, excuse me? Well, if I grab my handy dandy calculator, I can see that 54, ooh, I accidentally hit a menu button. 54 divided by 3 does give me 18. So I can say that yes, that does simplify down. So it is also 18 over 1, which, ooh, okay, we're seeing it again here. But let's double check our last one. Let's really make sure these are proportional, because I have to make sure the entire table is proportional before I can say it's proportional. And then again, 72 divided by 4 gives me 18 as well. I meant to write equal signs in between those. So because each ratio, simplifies to the same value, I can state that, yes, his earnings are proportional the number of hours he spends mowing. Next one. Uptown tickets charge $7 for a baseball game, a baseball game ticket, plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Explain. So again, we have to see if it's proportional by seeing if they're equivalent ratios. To determine equivalent ratios, they have to reduce the same value. So 10 over 1, well, that one can't reduce any farther. 10 over 1. 17 divided by 2, however, gives me 8.5. That's not 10. Well, what about 24 over 3? That just gives me 8. 31 over 4, that gives me 7.75. So are these proportional? Hopefully you're all saying no. No, the cost of tickets are not proportional. And why do you think that is? Let's discuss why. Because it's asking me to explain. It's not proportional because the ratios are not equivalent. Yeah, in the wrong spot. Number 3, you can reuse the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. And by this, it's pretty much like if you were making Kool-Aid. That's what that means by mix. So you have to mix the powder stuff plus the sugar plus the water. So what I want you to do is pause the video, see if you can figure out if this example is proportional or not. So just to double check with this one, I wanted to go through it because I know you are dividing fractions. It's talking about the amount of sugar to mix. So technically you would divide a half by 1, which is a half. Then you would take 1 divided by 2, which is a half. And then you take 1 1/2 divided by 3, which is the same thing as 3 over 2 divided by 3, which we just did on our test, which is 3 over 2 times 1/3, which is 3 over 6, which is a half, gentlemen. And then my last one of 2 over 4, which is a half. So I can say definitively, without doubt, because I did my math. Yes, the amount of sugar is proportional to the amount of mix needed for our fruit punch. At the beginning of the year, Isabel had $120 in a bank. Each week she deposits another 20. Is her account balance proportional to the number of weeks of deposits? Use the table below to explain your reasoning. So when she first starts out, she has $120 in the bank. That's going to be week 1. Each week she deposits an additional 20. So 120 plus 20 would give me 140. And then 140 plus 20 would be 160. Is her account balance proportional to the number of weeks? Well, I start with $120 in week 1, which can't reduce. I mean, it'd be 120. Then I have 140 in week 2, but that could reduce down to 70. Not equal. And then in week 3, I have 160, which reduces down to, I divided by 2, not 3. I'm a goofball. I just realized that. $53 and change, which is definitely not equal to that. So is her account proportional to the amount of money? Hopefully we can, we've already decided and said, nope. Her balance is not proportional. Her balance is not proportional to the amount, oh, that was redundant. The balance is not proportional to the number of weekly deposits. Or deposits per week. I like weekly deposits. It's shorter. And last one. The table shown represents the number of pages Martin and Gabriel write over time. Which situation represents proportional relationship between the time spent reading and the number of pages read? Ooh. Why don't you pause this one? I want you to try it. Figure out who has the proportional amount. Okay, so once we get this done, we should see that Martin had the proportional amount. Every increase in his table reduced down to 2 pages for every 5 minutes. Since that is a constant rate, he is proportional. He has the proportional amount of time. And oh, darn, we're out of notes.